Hello everyone. In this lecture, I am going to explain about the classification of the data structures. That already in previous video we had discussed, the basic classification of data structure is primitive, non-primitive. Examples for the primitive data structures, integer, float, character, and Boolean. Non-primitive further classified as a linear and non-linear data structures. In linear data structures, static and dynamic. In static, we have a array is the example, and for dynamic, we can give the linked list, stack, and queue as the examples. Non-linear data structures are two types, that is the trees as well as graphs. So this classification only in detail we can understand here. The difference between the primitive and non-primitive. Primitive is the primary level. The meaning of primitive is the primary level. Means whatever the data we are giving to the system, if it is a primitive data, it will be identifiable in the low level architecture of the system. System will be understanding the data directly without any interface. That is the primitive. Non-primitive means some of the interfaces are required to get these identity in the system. These interfaces are nothing but a primitive itself. That's what non-primitive are, the derived data types from the primitive. And with respect to the complexity, we need to differentiate. Primitive data structures are very simple and predefined, used for the basic data storage. Whereas a non-primitive data structures designed for organizing collections of data. In primitive, for example, if it is given int A means A is a variable which is of the single allocation, means single value it will be stored here. 2 bytes allocation and 1 value storage. If we have a float X, that float identity 4 bytes allocation and 1 value of the size 4 bytes we can input here. Like this here, it will be of the single variable allocation. Whereas in case of the non-primitive, we have a group of allocations we can take here. That is int A of 10. A of 10, it is the array. What is the size? It is given 10. Means 10 different values we can store here with a single variable name, that is the A. Like that, we have a of 20. 20 different values we can store in the single variable name A. So here multiple allocation it will be coming. So these multiple values operations will be complicated comparing to that of the single value. And mutability. Mutability is nothing but this is the property of the changeable. That is primitive data types are the immutable. Means these are not changing here, whereas non-primitive, they are of the mutable. See here we have a int, it is of 2 byte allocation. So that 2 byte we cannot change. Once the system configuration it is fixed for the integer allocation 2 bytes, it is fixed only, no any variation. Like that we have a float. Float it is of the 4 bytes, no any changes in the allocation. But when it is of the non-primitive, it is a mutable, means it will be changing. Suppose now if I say A of 5, 5 different allocations, 5 different values it can store here. That only A of 10 means 10 different values it can store. Depends on the user defined size, the allocation it will be taking. That's what it is, a mutable. And storage. Primitive data types are stored directly in the memory, whereas non-primitive data types are stored as a reference to their values. Means user defined. Non-primitive are the user defined, whereas primitive it is predefined. And like that only, here we have a linear data structure classification. Linear means consecutive allocation. When we have a allocation, structuring of the data, it will comes in the consecutive location. That is called as a linear data structure. Examples in that we have a arrays, linked list, stack, as well as queues. So first of all, here we have a array. Array is a collection of homogeneous data element consecutively allocated here. And we'll be creating the array in this way, that data type followed by the array name and its size. So here we have a array 5 means we have a 5 allocations of the integer type. Total allocations, each integer if we consider 2 bytes, total allocation will be 10 bytes allocation. And different values, 5 different values it will be stored here. And the index it will start from 0 and up to n minus 1 for the given n elements. N equals to 5 it is given. So it will be allocated up to 4 here. And this array 0, array 1 and all, these are indicating the values. and 0, 1, 2, 3, 4, these are the indexes. And what is the value it is stored in that respective allocations that it will be illustrated with this. Then next we have a linker list. Linker list also it is a linear data structure in which we have a consecutive allocation of the variables. So information will be stored in the form of a node. Node will be having two partition here, one partition for the information, another partition for the link. So there is a link from one node to another node. Like this, it will be having the link with the further nodes. The first node, it will be pointed with the head, and the last node will be pointing to the null, indicating the termination of the list here. And like that only we have a doubly linked list in which we have a insertion and deletion traversal will be both the side. And along with that, we have a circular linked list and all different data types we can discuss in the further videos. And next is the stack. Stack also it is a linear data structure. Also it is called as abstract data type. And it will take the allocation and deallocation of the values in the form of last in, first out. So as the stack, it will be having only one end. The insertion and deletion will be possible only through the same end. Now this is an open end through which we can insert. And when we are deleting from the same end, it is required to delete. So insertion, it is taken 10, 20, 30. And while deleting, the last element which is inserted to be deleted first. This operation, it is called as the push and pop. Push is insert and pop, it will be delete here. And like that only next we have a queue. Queue also the linear data structure, which it will be having. It is also the abstract data type, same as the stack. But here it will be working in the form of first in, last out methodology. So here we have a first in, last out means it will be having both the open ends from the both the side. Here insertion from one end it will be taking and deletion from another end. From front end it will take a deletion, whereas the rear end it will take a insertion. Insertion is called as a NQ and deletion it is a DQ. So these are the different linear data structures we can notice here. And non-linear data structure, which it is not arranged in the consecutive manner, it will be arranging in the hierarchical form. So here we have two types of the non-linear data structures, trees as well as graph. Tree, it is a hierarchical storage in which we have a data will be represented with a node and the edges are represented with the link. And it is not having any cycle here. We can notice this is called as a tree. Like that only, graph is nothing but a tree itself, but it will be having the cycle here. Cycles with the tree, it is called as a graph. Graph means with cycles, and tree without cycle graph, that it is called as a tree here. This is all about the different classifications of data structures. In further videos, we can continue with the practical implementation and all. Till then, goodbye.